How do these questions, taken together, help to illuminate the critical relationships between crystal structure, compositional modification, and the resulting electrochemical properties? And in what ways might the insights gained from such inquiries pave the way for innovative approaches to energy storage materials design? How does the schematic structure of Na2Fe2SO4 reveal the arrangement of its constituent atoms? And what specific structural motifs, such as the connectivity between iron centers and sulfate groups, are evident in the design that could influence its role as a cathode material? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? In what ways might the observed spatial configuration create ion transport channels that facilitate the movement of sodium ions during battery operation? And how does this structural organization correlate with the overall stability and performance of the material? What insights can be gleaned from examining the charge and discharge curves of Na2Fe2SO4 and how do these curves reflect the electrochemical properties such as voltage plateaus, capacity, cycling stability, and any potential kinetic limitations? How can variations in the curves, including the shape, slope, and plateau regions, be interpreted in terms of underlying redox reactions and the efficiency of ion diffusion within the crystalline framework? What experimental techniques, such as X-ray diffraction or electron microscopy, might have been used to determine the schematic structure? And how do the results from these methods validate the connection between the microscopic arrangement and the macroscopic electrochemical behavior observed in the charge-discharge analysis? How might subtle deviations or defects within the structure impact the performance metrics observed in the curves, and what strategies could be proposed to optimize both the structure and the electrochemical performance simultaneously? In what ways does the interplay between the material's schematic structure and its electrochemical response provide a more detailed understanding of the mechanisms that govern battery efficiency and durability? And what further questions does this raise about potential modifications, such as doping or compositional tuning, to overcome any identified limitations? How do these interrelated inquiries encourage a deeper exploration of the fundamental relationships between crystal structure, ion transport dynamics, and energy storage performance in next-generation sodium-ion battery materials? How does the crystal structure of Na-SO4F materials influence their overall electrochemical performance, and what specific aspects of the atomic arrangement, for example, the coordination geometry, bonding interactions, and symmetry, contribute to effective ion transport and stability? What?